Hello everyone, welcome back. We were creating this program function for computing the square root of a real number, and we have already seen how to compute it using a linear search routine, and we have just finished implementing the binary search routine, and we have implemented all different cases. And we said that in the last video that we are going to implement a faster search algorithm, which was designed by a Greek philosopher, he was also a Greek mathematician who went by the name Heron of Alexandria. Um, some people assume that the Babylonians knew about this algorithm as well, but I cannot really say it for a fact. But it was documented that Heron of Alexandria did make this algorithm. So it is based on Heron of Alexandria, and the algorithm goes like this. What you do is you start with a guess. Let's say you call it G, and then what you do is you check if the G square value is like close to the value for which you want to compute the square root, then you actually just return G, so small g here. And if this is not the case, what you do is you update G by just doing this. So you do G plus value divided by G. So you add value by G to G and divide the whole thing by 2 and use this value as the new value of G and repeat the process. So you go back to the start, and usually the initial guess is considered to be 1/3 of the value. So that's how the code of so that was the algorithm for computing square root, which was designed by Heron of Alexandria. Excuse me. And we are going to implement that algorithm. So what we name this algorithm double Heron of Alexandria, and we take the input as double value. And what we do initially is we just do this. If the value is less than 0, change the value to a positive value, because we know that the value must always be positive. Let's change it here. And then what we do is we do similar computation like before. We copy all these things here, and then we do a while true loop. So it's always true unless a certain condition is satisfied, which is let's say, where is guess? Let's copy paste a few things from here. So our initial guess is going to be, let's say, double guess, as we said, is 1/3 of the value divided by 3.0, and we put it here. So we compute the multiplication, we get the absolute error, and if the absolute error is less than a certain closeness factor, less than or equal to a closeness factor, then we return guess. Else what we do is we update the guess by guess plus guess divided by, sorry, not guess, value divided by guess, and then we divide the whole thing by 2.0, and then we do this. So let's say we want to number of guesses, we want to print the number of guesses that it took to find the solution. So here we say that so we copy paste some of these lines from here because it's almost the same thing. We go here and paste it here, and if this didn't work, in that case we have to update the number of guesses by 1. Plus, and one other thing that we want to do is if the value is less than or equal 0 or 1, we just return, we don't even have to compute. So let's do it here. So now if we run this code, we'll see that we'll see how things work. So we have already added the Heron of Alexandria code here, so we can just do Control R and let's check and compare the different results. So let's compute for 5, and we see that with the linear search it's 22,000 steps to this solution. With the binary search it's 8 steps to the solution, whereas with the Heron of Alexandria it's only 2 steps. So Heron of Alexandria was very smart guy. Apparently he solved these problems, I don't know, at 10 BC or AD, I think. Let's check. I think it was, yeah, it's 10 AD, somewhere during that time he solved this problem. So in between these 2 times he has solved it. Very smart guy. Let's try and run this for any value between 0 and 1. So with, let's say, 0.5, we see that the result is very close to binary search. However, it is and has a better result compared to binary search, even with the 4 steps. Okay, so now we have seen 3 different algorithms to compute the square root, and I hope you understand the importance of selecting algorithms and the importance of selecting a proper algorithm to solve any computational problem. I hope it helps you. Okay.